So this problem is illustration 3.5. So I have skipped illustration 3.4. Okay, so blocks A, B, and C are placed as shown in figure 3.12, this figure. Okay, and connected by ropes of negligible mass. So block A weighs 30 newtons and block B weighs 20 newton. So that is block A, okay, weighs 30 newtons and block B weighs 20 newton. And the coefficient of kinetic friction between block A and the horizontal surface, okay, is 0.31. That of block B and the inclined plane is 0.26. Block C descends with constant velocity. Okay, so find the tension in the rope connecting blocks A and B. So this rope, the tension here. And what is the weight of block C? Weight of block C. And for the third question, if the rope connecting A and B is cut, okay, and what would be the acceleration of C? Okay, what will be the acceleration of C? Right now, for the first question, find the tension in the rope connecting blocks A and B. So tension on this rope. Okay, so first things first, you need to draw an FBD. So let's say block A. Let us consider block A. Block A, okay, then horizontal surface, okay, similar to this one. Then let's say that is a block. Okay, now we always said that weight has a downward direction. Okay, that is due to gravity. Weight downward. Normal force is perpendicular to the surface, and the tension of the rope is given as T1. Okay, that's the tension of the rope, similar to the figure. Okay, then coefficient of frictional force acting on block A. Okay, if the motion is going on this direction, okay, the frictional force is opposite that direction. So the weight of A is given 30 newtons. So we don't have to solve for the weight. The frictional force on A is given the formula of mu and normal force. So that is 0.31 multiplied by normal force acting on A. Okay, but we don't have yet any value for the normal force. Now from the FBD, summation of forces along X equals 0. Why 0? From the previous example, we have used summation of forces along X will be equal to MA, right? From that previous example, we have assumed that the object or the crate is in motion. Now, we have set summation of forces along X equal to 0 because we will assume that these crates or these figures is in stationary, non-moving. Okay, so there is no motion yet. Now, we assume that there is no motion, so therefore summation of forces acting along X will be equal to 0. So horizontal forces, okay, so positive direction will be along the X and the negative direction is to the left. Okay, so this is positive values and this is negative. Okay, so now T1 moves to the positive X or positive direction, so this value is positive, so positive T1 anymore. So frictional force on A is negative, so that is minus frictional force on A will be equal to 0. So there are no more horizontal components. So therefore, T1 minus the frictional force on A is 0.31. Okay, will be equal to 0. Now, that will be our first equation. Now, summation of forces along Y is 0. Again, we have assumed that the given objects are not moving. Okay, so first says Y vertical component, so that is Y is down, so downward direction is negative. Okay, and upward direction, okay, positive. Now this is positive normal force and negative is weight, so therefore normal force minus weight of block A will be equal to 0. So therefore weight A is given 30 newtons, so you can solve for the normal force. Now we will substitute the value of the normal force to equation 1. So therefore you can solve for tension 1. So that is T1 minus 0.31 normal force, so 0.3130. That is the normal force. So simplifying this equation, you'll get 9.3 or 9.30 newtons. So that is the tension acting on the ropes between or connecting blocks A and B. This one and that one. Okay. Now for the number 2 item, what is the weight of block C? Again, from the previous number 1, we have assumed that it is non-moving or in stationary position. Same goes with number 2. What is the weight of block C? Now we need to draw the diagram of or FBD of block B. So FBD or free body diagram of block B. So inclined, okay. So this surface inclined, then the block, and then the weight serves or is always pointing downward. Don't forget that. Okay, the normal force is always perpendicular to the surface, forming 90 degrees. Then the frictional force, if that is assumed movement, is along this direction, so that's opposite that direction, and tension 1 is connected to block A, right? So there's a tension here, there's a steel rope here. Okay, then tension 1, recall, that is 9.3 or 30 newtons, and that is tension 2 on this side. Okay, anymore? Okay, now based on the weight, there's two components. Okay, so you should be perpendicular always to the surface. So you'll draw uh, an x and y component here. This is your positive x and that is your positive y. Okay, uh, so using that, you have a y component and this is the x component, okay, of the weight. Okay, horizontal and vertical, those are only considered. Weight B is not uh, applicable to horizontal and vertical components, so you need its horizontal and vertical components. Okay, so the weight of B is 20 Newton based on the given. Okay, now the frictional force on B using similar formula. Okay, frictional force on B, so that is mu normal force. So mu is 0.26, normal force of B is not yet given. So from the FBD of A, okay, since it is stationary, non-moving, summation of forces along X is 0. So X components or horizontal components, T2, T1, this one WB cosine 36.9, and the frictional force. So therefore, positive direction is to the right. So positive T2 minus T1 minus weight cosine 36.9 and minus frictional force will be equal to 0. Simplifying the equation, you get an equation 1. So T2 is equivalent to 9.3 plus 20 sine 36.9. Weight of B is given. Okay. And frictional force, we had an equation here. Okay. Uh, Now summation of forces along y will also be equal to 0. So all the vertical components, so this is going up, this is positive, and this is going down, negative. So that is NB, normal force, minus weight of B cosine 36.9 degrees will be equal to 0. So that is the normal force can be solved, and the value is 15.99 newtons. Now we substitute that value to equation 2. So T2, 9.3, 20 sine 36.9 minus 0.26, and B is 15.99. So you'll get the tension 2 of 25.47. So we are not yet done because the question is, what is the weight of the block? Okay, now let us consider block C. FBD of block C will give you this one. Okay, so block C, the tension of this rope and its weight. So those are the components. So tension of the rope by T2 because it is connected to block B. That's why this is equal to T2. Same goes with this one. This is T1 on this side because it is connected to block A. Okay, so T2 going up, and weight is always in downward direction. Okay, so weight of the block, so there are no horizontal components, so summation of forces along y will be equal to 0, and that is T2 is positive minus weight of, oh, this is C, I mean weight of C, sorry, this is weight of block C. Now T2 is given, right? T2 is 25.47, and that is negative minus weight of C. So this becomes positive WC. So WC, or weight of the blocks C, will be equal to 25.47 newtons. Okay, so that will be the final answer for number 2 question. And for number 3, if the rope connecting A and B were cut, what would be the acceleration of C? Now, if this portion is cut, okay, tendency block B and block C are the ones connected. So the question is, one of them will, so possible block B will slide, or if C weighs more, it will go down. Okay, so I'll just remove first block A, cut the rope, there it goes. Okay, now there are only two FBDs applicable, so for block B and block C. Okay, now FBD of B, you'll get this one. Okay, and so there's no tension available here because the cut is already the rope is already cut. Okay, so there is only a tension connecting the two blocks, so there's a tension here, tension 3. Okay, tension 3, and weight is always acting downward. The norm force is perpendicular to the plane, and if I assume the acceleration or motion of this block, okay, is going downward, okay, this is the movement of acceleration, so block B will slide up based on my assumption. Okay, so acceleration. Now, the x and y components of weight is given, similar from the given before. Okay, now reminder that frictional force acting on B is still the same, which is 4.60 Newton, and weight of B, it doesn't change, which is 20 Newtons, and the normal force of B is 15.99 Newtons. Okay, now from FBD of B, okay, so considering movement or motion along X, okay, so if there is motion or movement, summation of forces will not be equal to 0. Okay, so it should be equal to mass acceleration. So summation of forces along X, okay, considering the motion, okay, T3 positive minus WB cosine 36.9 minus its frictional force will be equal to mass of B multiplied by acceleration. Okay, so there's motion here. Now simplifying, you get weight of block B is 20 and frictional force 4.16. So this serves as equation 3. Now considering FBD of block C, okay, same from before, but then there is motion. So if block B, if the motion assumed for block B, okay, following this direction, so the motion of block C is going down. Okay, now, okay, so summation of forces along X, okay, is equal to MA. Why did I use summation of forces of X? But this is Y, right? So if I will assume the motion is along this direction, okay, the movement of this motion is along the X axis using this one. So this is X and that is Y. So the motion is along X. Okay, so if I will draw a horizontal surface, okay, based on that surface, this is block B. The motion is along X and this is connected to C. Okay, and this is in downward direction, but then the motion of this will also be along X. So that's why I have used summation of forces along the x-axis. So this will be the weight based on this one, okay, and this will be tension on the rope, T3. So this is T3. Okay, so summation of forces will also be equal to mass acceleration. So mass of this is mass of the grade C. So that is motion or movement is to the right. So the weight is positive, right? That is on the positive x-axis, and T3 is negative. Okay, so that is why positive weight minus negative T3 will be equal to mass of crate multiplied by acceleration. So weight of the crate is 25.47, okay, minus tension 3 is not yet given, okay, mass of the crate acceleration. So this serves as equation 4, okay, equation 4. So that is equation 4. Now, oops. So continuation, we have to add equation 3 and equation 4. So adding equation 3 and equation 4, so equation 1, okay, Okay, and equation 2, 4, 25.4 minus T3. Okay, now since we add these two, we need to add them. So T3 minus T3 will be eliminated. So that gives you 25.47 minus this one will be equal to MBA plus MCA. Okay, simplifying the new equation, this one, simplifying this equation, you get 9.3 will be equal to mass of B plus mass of C multiplied by acceleration. So factoring out acceleration, okay, now we need to recall that weight is equivalent to mass multiplied by acceleration due to gravity, and mass is equal to weight all over acceleration due to gravity. So you can say that 9 mass of B is WB. Okay, WB is 20 all over 9.81 plus mass of C is 25 point, weight of C is 25.47 all over 9.81 multiplied by acceleration. Then simplifying this equation, you'll get an answer of 2.01 meter per second squared, and that is the acceleration of crate C.